Alright folks, so it's the night before your exam. What I'm going to do in this video is I'm going to briefly present 3 different theorems, and I'm not going to narrate them as much as I did. I actually recorded this video earlier, and then the people next to me were cursing so loud that you could hear it in the video. So, take 2. These are only going to be from the optional exercises. Actually, I'll just do everything. But let's start with the theorems. So theorems are such that you have no given premises, and you're only given a conclusion. And then you're asked to work backwards in order to figure out how can we show that this conclusion follows more or less in and of itself. My main recommendation, if you see a wedge, do a reductio. I also recommend if you see an arrow, do a reductio, but we'll talk about that later. Let's start with this. I'm going to do a reductio for this one. So let's start with a reductio. So it's not the case that the entire conclusion that we want to prove is true. Assumption for the sake of a reductio. Then we're going to De Morgan's it to get negation P and not P arrow Q. 1 DEM. Break those pieces apart. And then for line 4, you can use a substitution instance to get P and not Q. Then we can break off the P and the Q. You don't have to break off the Q, but let's just go ahead and do so. And then since we have a contradiction, negation P and P, let's make the contradiction explicit and say it's P and not P. So that's going to be line 3 and line 6. Since we've shown that line 1 leads to a contradiction, we're going to be able to discharge the contradiction, or discharge the assumption. But remember, since we have a negation in our assumption up here, it turns into it's not the case that we don't have all of this stuff. Then we use double negation to drop off the 2 negations. If you skip this step and try to skip straight to here, you're going to get marked off points. So don't do that. And that's just 9 DN. For the assumption numbers, we write an assumption number that matches the line number for every assumption that we've been given or that we introduced. Since we weren't given any assumption numbers, we're only going to write it down for the one that we introduced. And it's going to be 1s all the way down until we hit the line where we discharge the reductio. Since we discharge reductio, we cross it out. So here's theorem number 1. Now we're going to do theorem number 2. Don't think we need this many lines, but I'm just going to write some just in case. So for this theorem, we're going to see that we have the following. Since the operator here, the main operator is a wedge, we're going to do a reductio. That way we can De Morgan's it later. Then De Morgan's. Break it apart. And then for 3 and 4, we can use substitution instance 35G since it's a negated arrow. Three, 4, SI, 35G. Here we can see that we have a negation Q and a Q, but we need those pieces isolated so we can stick them together. So break them off from their and statements respectively. And now we can stick them together. Since we've shown that our assumption up here has led to a contradiction down here, we're going to be able to discharge that assumption. But remember, since we assume something with a negation, we have to do this first. And then double negate. The assumption numbers here are going to be a little bit interesting. So we're going to initially write an assumption number down for 1 because that's the only assumption we have at all, namely it's the one we've introduced. And then it's 1s all the way down until we hit line 10. Since that's a reductio line, we're going to discharge the 1. So notice that on line 11, we don't have any assumption numbers written down, and that's as it should be. Since if we weren't starting with any given assumptions, we shouldn't be ending with any assumptions either. Okay, let's do one last theorem. This is going to be C. You could do this with a conditional proof or a reductio. I'm going to show both. So let's start with a conditional proof. We would assume the entire antecedent, which is all of this, assume for the sake of conditional proof in order to reach P, but note that there's no arrow over here, so we're not going to be doing any additional conditional proofs. This was it. But now we're going to be stuck. There's nothing else that we can do right now. So we're going to do a reductio. We're going to assume not P. Why? Our goal over here is P, and given that we have a system that is consistent here, if we assume the opposite of that, we'll be able to reach a contradiction eventually. Assume for a reductio, and then that's going to, with line 1, via modus tollens, give us not P arrow Q, which gives us P and not Q via SI 35G. Notice we use 35G a lot. We're going to break the P and the not Q off. And then we have a contradiction with not P and P. So let's make the contradiction explicit. 2, 5, and introduction. Since we've shown that line 2 led to a contradiction, we're going to be able to hop back out to the red line and say that it's not the case that we don't have P. Remember, since we introduced a negated thing for our reductio, we're going to have to use double negation somewhere down the line, in this case in line 9. But for line 8, it's from 2, 7, RAA, then 8, double negation. Since we've shown that line 1 leads to P, which is our goal, right there, we're going to be able to finally hop out and say that P arrow Q arrow P implies P from lines 1, 9, conditional proof. For our assumption numbers here, we're going to put an assumption number that matches the line number for every assumption given or introduced. Line 7 is a reductio line, so we discharge the 2. Then we have a 1, a 1, a 1, but then we discharge it. So that's how to do this one with a conditional proof. You can also do it with an RAA. So let me demonstrate that right now. It's not as pretty to start with because of all the brackets, but that's okay. So since the main operator is an arrow right here, we're going to use a substitution instance. So notice that between lines 3 and 4, we're going to have a modus tollens situation. So we get that it's not the case that P arrow Q. 3, 4, and TT. Now, a negated arrow can be made into P and not Q via one of the rules that we learned. Namely 35G. Again, 35G is very common. Break off the P. Stick the P and not P together. And since we've reached a contradiction, we're going to be able to say that what we assumed earlier has to be false. So it's not the case that we don't have all of this stuff. Then we use double negation. The assumption numbers here are a little bit more straightforward because we start with a 1, and then it's 1s all the way down until you discharge it at line 9. And then note that we end with no active assumptions in line 10, and that again is as it should be. So this was theorems. There is plausibly going to be a theorem on your exam. I can't guarantee it, but it seems very likely. So make sure to study these.